So, hi everyone, and welcome to the community meeting for June 2026. And I want to just thank Jose a lot that he is going to be presenting what they're doing in OpenFGA in Datum. So, pretty cool to have you. Thank you. And before getting there, we're going to start with our usual agenda. This is what we do is we have introductions for the members who are community members who are new to the call. If they want to introduce themselves, that's awesome. We do just ship demos or presentations, discuss what's next, share some community news, and then wrap it up. This is our team. Some of the team members are here, ours not, and close to each one is the country where they identify with. There might be where they live, or maybe where they were born, or both. And so you can see that. And if anyone wants to introduce themselves, is the first time in the call, or you just want to say hi again, please go ahead, and then we'll continue with the meeting.
Hey guys, so hi here. Hi there. My first time at the OpenFGA community meeting. I'm so excited to be here. I had a great opportunity that Andres contacted me through LinkedIn. He saw our work on OpenFGA and invited us to show our implementation of your system. So I'm just so happy to be here. I'm really thank you for the great work that you did with OpenFGA.
Thank you, Jose. Anyone else wants to share some words? Okay, good. So since we've been working, so we shipped a lot of minor releases, a lot of with small bug fixes. We are getting a lot of just in a way random security reports based on people using AI tooling to and find obscure things that we are addressing and shipping. So we are like shipping more often than usual. In most cases, and in every case, they are not significant security issues, but we are kind of fixing them all. And we've been in last week we shared the work we're doing with this new weighted graph algorithm that we're implementing for check. Right now it's under an experimental flag called weighted graph check. We're very close to push that to production. It's working in check, not in bat check yet. We are wrapping that up to push it. The results we've seen with the production customers in our hosted version were great. So like a very important reduction in P99 latency. So we are pretty excited to see how that works in your models and what effects you see. And then we fixed small things here and there. And we're going to thank Francisco and Abdul for their first and contributions to OpenFGA. So thank you guys. And now I will pass it to Jose, who will help us understand how they are being using OpenFGA at Datum. I've been looking at what they've been doing and monitoring the repos for a while, until I decided to reach out to them. So I think it's going to be pretty interesting.
Thank you for the presentation. I'm going to explain to you how Datum using OpenFGA for our Milo OS open source system. And Milo OS is our system of action that is specialized for cloud providers. So before we start about explaining how we're using OpenFGA, I would like to explain what Datum is. Here at Datum, we are building a connector infrastructure for AI. We are in a main mission for helping cloud providers to thrive in the AI era. We can provide our global public edge cloud, and we also offer dedicated infrastructure and services. Everything is backed by open source. So the same code that we use is the one that you can use at your own project. And then we have Milo OS, which is our system of action, is the one that implements OpenFGA. Milo OS underpins our business logic. It's designed to help us to drive all of our interaction with the user and customers, but it's also designed to any cloud operator to use it. Three very important things is that we are fully open source. Milo OS is designed for operators to drive their needs to business operations, and everything is built for hyperscale. This was a scale as a first class feature here at Datum. So As Datum is the system that drives our services and cloud computing, Milo OS drives our business logic. It's built on Kubernetes, and everything in Milo is custom resource definition. So it just provides all of the tooling and services that any cloud provider needs for driving their business. We offer all of the business logic for organization, projects, users. We have our own CRM records. Milo offer a system for billing to the users, agreement system, limit usage through quotas. We also have system for notifications and marketing communication. So this is very important. Everything here is defined with a Kubernetes custom resource definition, which is great because we can use a single subject access review webhook that will grant authorization or authentication checks against any user or customer that wants to get a custom resource. So here is where our main issue started a few years ago. We wanted to build a system that had these structures in which we had maybe I can. Okay, I have the lesser point here. We wanted to build a system in which we had an organization. Under these organizations, users can have one or many projects. And inside these projects, all of the workloads, networks, or services lives in. So we wanted an easy way for a user to be granted a role at an organization level, and in which they can easily inherit the permissions to the project and services inside that project. Using default Kubernetes RBAC is difficult. It doesn't provide the tooling for doing that. Kubernetes RBAC is flat. It doesn't provide an inherited system. That means if you have a binding for an organization, it will reach to the project. It also have a scaling ceiling because if a user have 100 projects, if you use this Kubernetes RBAC, it will require 100 bindings, which is very difficult to scale. So after many decisions, we took a decision that in fact it was a cascading issue. It was a graph problem, and that we will require a graph engine. And this is where we find OpenFGA. Because as we see here, everything in OpenFGA is just a graph. It allows us to define the edge for defining permissions. So for example, in our structures, we have project, and projects have a parent organization. In OpenFGA, it's really easy to build a model schema that match this structure. And it's also very easy to define roles. So we can say, okay, so if you are part of this organization, and the organization is a parent of the project, the user have access to certain resources inside that project. It was also great to us because OpenFGA allowed us to build the corrective model. We want to leverage all of the responsibility for authorization to a third-party system. So we just have our API server, which asks to our internal authorization provider if a user have access to a resource, and OpenFGA is the engine that is going to evaluate this and say if user can or can't have access. OpenFGA allowed us to create policy system which everything is defined through a custom resource definition. Our API servers or controllers doesn't handle any kind of authorization, which is great because if we need to make an authorization change or if we have a new resource and user shouldn't be able to reach to that resource, we don't touch our code, we don't make any deploys, we just write some resources to our authorization provider, which syncs with OpenFGA, everything at runtime, which is great. And it also allows us to make bug check, so we can send authorization check in parallel to OpenFGA and gives us very low latency checks. So here is a quick read path. Here we have our Milo API server and we have a user. When a user wants to have access to a resource, it creates a request with their access token. a verb, and a resource. Our authentication provider validates the token. Once they are authenticated, Milo IP server will reach to our authorization provider with the verb and the resource. And then this gets forwarded to OpenFGA, which is going to take the decision. The user can have access to the resource or can't. After that, the decision reach to Milo IP server. We just bring the resource or return an authorization error. This is great for us because Milo IP server doesn't handle any kind of authorization logic. Everything is delegated to our authorization provider. We just ask to OpenFGA. But of course, we also have a waiting path because OpenFGA needs to get on sync with our system with all of the permissions that are granted to different users. So we have an operators that just apply a custom resource definition into our Milo API server. And then inside our authorization provider, we have many controllers. One of them checks for the resource named protected resource. That is the ones that write the OpenFGA model schema. And after that, we also have policy bindings that a policy binding says, okay, so this user can have this role under a certain resource. And we have also a role customer resource that just holds a bunch of effective permissions. So I think just to make everything clear and really understand how our system works with OpenFGA, I'm going to explain how each one of these custom resource definition works and what they do on the OpenFGA side. First, we have our protected resource, which is just a resource type with the verbs and a parent. This inside OpenFGA is just a type with the relations. It just build the model schema. We have a role. A role just included a bundle of permissions. This doesn't reach OpenFGA, but it has all of the permissions that can be assigned to a policy binding. Next, we have our policy binding that just say, okay, so this is a subject, this is our user, assign this role for that specific resource. In OpenFGA, it just builds the permission tuples. We also have groups, which is a shared object that will create an internal user group object in OpenFGA. And finally, we have our group memberships. A group membership is just between a link between a user and a group. It just creates a member tuple. So let's start with any of these custom resource definition. For our protected resource, we can see that it just defines a Kubernetes service reference. This is the full name. Also defines the kind. In this example, is project. And it defines all of the permission that this resource can have. Get, create, delete. They are optional fields. And after that, we can define a parent resource, which is completely an optional field. We can see that here, this becomes, in OpenFGA, is just a type, resource manager. It defines the relations with the parent and with the permissions. And that's it. Every protected resource that we create, it just helps to rebuild the OpenFGA schema model. Something important that you will see here is that in this permission, instead of having the full qualified name permission, we just use a hash of it. Why is that? Because when we try to add the fully qualified permission, OpenFGA wasn't allowing us to use / or some special characters. So for the effective permission, we just hash and have a deterministic value. So this allows us to don't need to create a lookup table. And as is deterministic, the webhook can also hash the same permission and is going to have the exact same result. So every time a protected resource is created, our model schema in OpenFGA receives the update. Then we have a role. A role, as you can see here, is just include a bunch of fully qualified permissions. It can have permissions for different protected resource. It is completely fine with that. And additionally, you can also include roles from another one. This doesn't write anything in FPGA. It is just a lookup table that the policy bindings are going to use. And this is our policy binding. This is how we actually grant permissions to a user in a specific resource. We see that our policy binding makes reference to a role. This role is the one that holds all of the permissions. After that, we have a subject. The subject can be a user, but we also support groups or services account. And very important, but not last, our resource selector. Here, you can select a specific resource reference. For example, this policy binding is going to be applied to the project, but specifically the project named my project, that this is going to be the project of a user of a project inside an organization. But we also have a more wide way to define a resource, which is by using a resource kind. That if you have a resource kind, this just get access to all of the kinds inside the cluster. This is just used by staff members of Datum. So as you can see here, when you use resource reference, it just creates one tuple per permission inside the role. It defines the user, the duration, and the object. And when we use option B, which is a resource kind, it references the root kind of the object. And finally, we have the group. A group is just an identity. What is great about group and how we implement it is that we have group, we can create membership tuples of different users to the same group, but the policy binding is applied only once. So we apply only once binding or many policy binding depending on the different roles to a group, and all of the users inside this specific group are going to carry the same policy bindings or the same permissions in the cluster. And of course, for being part of a group, we have the group membership custom resource definition. You just reference a user, and you also reference the group. In OpenFGA, this is just going to create a new tuple with the user, the duration, and the object. So this is how everything works together. I'm going to quickly show you two different examples. With this 5 custom resource definition, we can create only one graph. Let's see, this is example of a staff user, okay? This staff user is part of the staff members and is a member because here is a group membership, which is great. And this group have permission for getting workloads. It have this permission because this group have a policy binding that use a resource selector as a kind. So this group will be able to get any workload inside our system. Or we also have example of Bob. Bob here is just a regular user who have permissions for getting workloads. They have this permission because here there is a policy binding that assigned a role with this permission pointing to this organization. And of course, if we see the completed graph, the parent of this workload is a project, and the parent of this project is an organization. So as this policy binding has been applied to the organization, Bob is going to be able to get access to the workload. So something very important is that before I explained to you that the roles doesn't write any tuple in OpenFGA. So what happens when a role receives an update? It has new permissions, or we remove permission from a role. We have our one controllers that just verify that the permission actually exists because they were defined in a protected resource. And if all of the new permission exist in the system, the role will receive a status update with the effective permissions. When all of the permissions has been verified, our system, each policy binding have a controllers. So these policy bindings controllers will watch that the roles receive update. So it will just reconcile all of the policy bindings in our system. So depending on the change of the role, is going to, for each policy binding, is going to delete tuples or write the new ones. So what we can tell you about our experience of using OpenFGA in a Kubernetes system, where we highly depends of controllers for making the state of our system, is that we decided to not write roles in OpenFGA. We always resolve them into permission. We always try to make checks to OpenFGA direct and flat, because this really allows us to get extremely low latency checks. Something important that we really use cache for authorization. So we always try to store relationships as physical tuples, just to maximize OpenFGA check caching. And we also try to avoid using runtime evaluating context, because they don't get use of context of caching. I can slow down the response times to the users. Very important to always use a parallel fanout, because a user can have access to a resource in different ways, because they can have different roles, they can have different policy bindings that run the same authorization level. So we just make all questions in parallel, and the first one that wins with a positive, or that the user can have access, we just return the reply to the Milo IP server, so the user can have the authorization check very fast. And that's how, in a very fast way, which I try to describe our architecture for using OpenFGA for authorization.
Great, thank you, Jose. So I'm not and I don't know much about Kubernetes, so maybe someone can help me understand. So what is the value of expressing these policies or these objects and relations in CRDs instead of doing it regularly directly in tuples or in other way, another configuration way, right?
Well, in fact, this is great, because we are seeing Kubernetes API servers and controller logic. Every time we create a new resource, our system will try to reconcile the resource. It doesn't matter if it fails or if there was a connection issue. This allows the controllers to check the actual state of the custom resource definition. It will try to reconcile the resource till eventually the tuples gets created in OpenFGA. So this is just a great way that automatically out of the box gives us retry logics with exponential backups on all the necessary stuff to guarantee that these tuples are going to eventually be created in OpenFGA.
Makes sense. And then you mentioned that all the entities are in your system are defined also as CRDs, like so everything you manage that way, every entity in your system.
Yeah,
as CRDs.
This is fine. It's not just for Milo, but for all of the Datum resources, they are defined by CRD. Why? Because out of the box, Kubernetes system infrastructures, when you define a new custom resource definitions, it will automatically provide to you all of the API for managing the resource. All of the listing, get, pagination, all this out of the box. And as this is provided by Kubernetes, we can use the Kubernetes way for applying webhooks that make the authorization checks or the authentication checks. So we don't write any kind of custom logics and just reuse all of the tooling that Kubernetes brings to us. So for example, for making the authorization checks, as Milo is a Kubernetes API server, into the Kubernetes system, we just define, okay, when you need to make authorization, use this endpoint, which is our authorization endpoint that asks to OpenFGA. And this is already built logic and provided by Kubernetes.
Makes sense. Can you show me again the model that you use for OpenFGA?
Here, it's not a
Yeah,
complete
sorry.
model, but
The one. Yeah, yes, I assume. Okay. This is open source, right? So the model should be somewhere in GitHub, correct?
yeah, of course, you can check our repository. Maybe you can want to
I
take
tried
a
to find it, but I
screenshot.
couldn't. Yeah, that makes sense. Okay.
Here it is. You can see our OpenFGA provider. Everything is open source. You can just make a fork, clone our project, and just bring it into Kubernetes operator system. You will have authorization with OpenFGA out of the box.
Cool. Awesome. Anyone? More questions, comments?
Do you expect the model to change at all? I mean, it seems like a lot of things are pretty, it depends upon a pretty static model. So do you have the concept of a migration built in?
Okay, so you're right on this. We have a very defined model in which we have organization and project as parents for any resource on the system. So our model is quite static into that. We are not expecting to make any change, but it also have a change on runtime because every time you create a protected resource, we create a new model and just add this new protected resource into the schema. So when you create a new customer resource with the protected resource, we are going to create a new model schema that incorporates this change.
So you mentioned today you have organizations and projects, right? Do you have more entities in the model besides that, in the production model?
Well, in our production
project and root, yeah. Yeah, but in the production one, do you have more types than this?
Oh, it have many types. It have lots of more types. Yeah. In fact, we made some short decision for the presentation, but actually we have hundreds of types that can be different parents or just to build the custom model using the protected resource.
Okay, makes sense. Pretty cool. Yeah, I mean, I don't love this idea of the hash, right? Because of course it makes the model more difficult to read. I see why you did it. So that is something for us to figure out how we can help you there. So, and sometimes we hear people wanting to use kind of a name that is defined somewhere else, right? And they don't have control on as type definitions or relationships. This seems to one of those cases, right? Where it's important for you to just keep that string because it's the one you have somewhere else, right? And if we add restrictions on these things, that we need to have some limits on the characters you need to put, right? But on the other hand, we could be more flexible. If I don't know, for example, in this one, I don't see why we can't support slash in a relation, right? It's not a protected thing in OpenFGA, so we could potentially support it, right? And if we was hash, couldn't because we use it for other things, right? But for slash there could work.
So something important that at staff or operator level, in fact, we never see these hashes because the entire source of truth of our OpenFGA state is our customer source definition. So everything gets eventually in sync on OpenFGA, but we never are in touch directly with OpenFGA.
Yeah. So yeah, that makes sense. It's just an internal implementation detail that is a hash there, but it's not exposed to anyone, right? So it's not that bad, right? However, yeah, you have to do more work to make this work, right? And that we could avoid. Something else that you mentioned, is this thing that you kind of, so you mentioned that you pre-compute the permissions and the permissions are always direct checks, something like that. Can you elaborate on that? I think I got it
Here
wrong.
we
Yeah, that
define.
thing, like we resolve roles into permissions early, right?
Okay.
What do you mean by that?
Okay, this is here. Okay, so because the roles doesn't create any tuple on OpenFGA. So for
Hmm.
example, when we have, let's go to the policy binding, we
Okay.
can see that the policy binding reference to a role. When this policy binding reach to our controller will make a lookup into this specific role, and it will get all of the permissions that are defined into that role. So by
Okay.
just having the subject and the resource selector and the permission, we just proceed to create all of the tuples in OpenFGA. It just
Okay.
creates one tuple per permission inside that specific role.
Okay. So, and why did you decide to do that instead of having like a role and resolve this on the OpenFGA side? Is for performance because it should be fast, right? But it's
Mhm.
mostly for performance, and there are other reasons for doing this.
Okay, always for the way we work, we try to leverage most of the work to our controllers. So we
Okay.
really like to handle as much of the logic as we can.
Okay.
And we also thought that the most light way to keep OpenFGA flat and with low complexity was by just creating one to prepare permission. It was an architectural decision take a while ago.
Mm-hmm.
And at that moment, it works great. We saw it was a little faster. So
Mm-hmm.
we just decided to keep it that way. When, of course, when the policy binding reconciles, it have a little more work
Yep.
because it need to make a lookup into the role. But once everything is written, it just
Mm-hmm.
keep everything but faster for us.
Because yeah, I mean, and we improved performance a lot since in the last
Mhm.
year or so. So hopefully that is not an issue. But I see the value too, right? So if this is already there
Mhm.
and you can simplify it, yeah, it's gonna be simpler anyway, right? So simplify fast.
Mhm.
Osman, yeah.
Yeah, thanks, Jose. Very interesting approach. I have a question about the protected resource CRD. I think this is how you manage the model, right? If I understand correctly. And if every protected resource maps to a type, right?
Yes, that's correct.
Cool, cool. So my question is, if I remember correctly, OpenFGA doesn't have an API to update the model partially. So I guess whenever a CRD of this type is applied in your Kubernetes cluster, you need some way to aggregate all the protected resources and then build the whole model and then update the model in OpenFGA. Is that how it
Yes.
works? Okay.
Yes,
Cool.
that's exactly the way it works. As we don't expect protected resource to change that quite often, it only changes when a new service is created that it has their own resource study authorization. Every time that protected resource is created, we just create on runtime a new model that includes this new resource and reshapes the entire OpenFGA model. It just upload a new one.
Cool, makes sense. Then my next question is, did you run into issues related to race conditions? Because the way how Kubernetes works is that it's eventually consistent, right? You apply the resource, and then, as you said earlier, Kubernetes will try to reconcile the manifest and eventually update the model. So if two people applied two mutually exclusive protected resources, I'm not sure if you run into such problems or not.
Well, for using protected resource, we'll use FlagCD. So let's say, for example, we define two new protected resource. This is all made using GitOps operations. So FluxCD is in charge of monitoring the status of the protected resource. So it's going to keep trying to install the protected results. Still, all of them have a ready status condition. That just means that everything was applied together. So there might be a scenario in which there is a rest condition, but FluxCD will guarantee that all of the resources get correctly reconciled and get into the right state.
Makes sense. Thanks.
You're welcome. And something also valid is, for example, at the moment a user creates the first organization because they just created accounts into Datum. The policy binding gets created and it needs to be reconciled. So there could be a race condition in which the user tries to get into their new organization, but they don't have access to because the binding wasn't reconciled. But in fact, the reconciliation just happened in milliseconds. So we never had this issue or a complaint in which a user couldn't access to their just created resource in the system.
I have a question around the model and the relations. Generally speaking, so if you want to now go update or author or just see what your model is, did you build tooling that would translate these hashed relations back to what they should be, or like you never had this use case?
Oh, in fact, we never had the use case. We never had a use case of watching how the OpenFGA model looks like.
Okay.
But as our custom resource definition is the source of truth, in the case we need to do that, we'll just take our own resources and try to build the model using our information instead of using that from OpenFGA.
So you never have a need to look at the model, like you can just do your own thing on your side, and this is just basically an intermediary for as far as you're concerned.
Yes, that's correct. The way we do that this way, because in a scenario, I don't think it will happen. But let's say in the future we want to change OpenFGA for a different authorization provider, we can just keep our own model and just make the necessary updates into the controllers for supporting a different API in our system.
No, it's good because you can actually also completely at some point drop and rebuild your full OpenFGA system from scratch.
Yes, and in fact, this is how Milo OS works. With Milo OS, we provide authentication provider, which is Citadel. We provide authorization provider, this is OpenFGA. We have two different notification systems. One uses resends, another one uses loops. We also have a search system that uses mail search. And this is just modules that we give to the users. But if any users want to use a different system, it's completely fine. They can use the exact same custom resource definition and just change the controller logic to make the system sync with their different systems. So it just keep everything in a plug and play way. Everything is very pluggable and allows the user just to use the provider they want.
That makes sense. Yeah. Thank you.
You're welcome.
So thank you, Jose. So we don't have a lot more. So community news, we've been sharing this in the last couple of meetings. So Rahul is going to present in KubeCon India about their use case of how they're implementing OpenFGA in their company. If you're in India and you are close to, I think it's in Bangalore, and you're attending KubeCon, please go and let us know how it goes. Hopefully it's going to be recorded and we can watch it after. And so roadmap, there's not much more there. We'll be mainly focused on this problem for a while. We are about to wrap it up, and then we're going to do another set of performance improvements we're going to take more advantage of some SQL database constructs that we are not to do less database round trips. That we're going to do that on top of this weighted graph algorithm that's going to continue decrease latency and continue to make FGA faster. Right now, I think FGA is kind of the fastest product in the space, right? But we have more space to make it faster, and we all want to complete that work. And then, yeah, so please support the project, start a project if you haven't yet. And something that I will ping you later, Jose, is we have a page that is the adopters page when we list everyone who has been using OpenFGA. And I think the Datum is not there yet, so maybe we can work on having it there. And because that's of course important for us to kind of brag about how everyone is using OpenFGA and how great it was for them. So thank you, everyone, and we'll meet next month. We'll have a lot of very interesting companies that are going to present, and I cannot say whom. Some of them are kind of very known and large companies that nobody knows they're using OpenFGA yet, and they're going to be pretty amazing to understand how they are using it.
Just before we end, Jose, please feel free to share like the slides, any notes and links to your project on the CNCF channel, because a lot of people who did not join us would probably still benefit from everything you've shown.
Yeah, of course. I'm
Awesome.
just to share that.
Perfect. Thank you, everyone. See you next time. Bye-bye.
See you.